for a sample size of n is equal to 2, the quantity 1 upon sigma square xi minus x bar square simplifies to square of x1 minus x2 upon under root 2 sigma. If x1 and x2 are IID and mu sigma square, what is distribution of x1 minus x2 upon under root 2 sigma? So here what I feel is that this whole is a distractor and we only need to work with this. If there are two normal variables x1 and x2, then their linear combination, this is their basically linear combination. We can also simplify it as 1 minus under root 2 sigma x1 and x2. So you are just subtracting x1 and x1 from x2 and then multiplying it by 1 by 2 sigma, and we want to know what the mean is going to be. So the expected value of the combination is going to be expected value of x1 plus expected value of x2. In this case it is a subtraction, so expected value of x1 minus x2 upon under root 2 sigma is just going to be we're gonna multiply this is going to be this can also be written as x1 upon under root 2 sigma minus x2 upon under root 2 sigma. So you're just multiplying it by the under root 2 sigma. So this is going to be this is mu, expected value of x1 is mu, and you are dividing the mu with, so mu, and this is minus, so this is mu minus mu because they both are mu, and then you are multiplying it by 1 by root 2 sigma, and mu minus mu is going to be 0, so d rho divided by under root 2 sigma is just going to be 0. So that is why the expected value of this combination is going to be 0. And then what is the variance? So variance is supposed to be added irrespective of the sign. So then all you have to do is sigma 1 square plus sigma 2 square, and it gets multiplied by 1 by root 2 sigma. So that becomes and it's a and you are multiplying this constant. So when you're doing sigma, the factor that you multiply becomes squared. So that is going to be 1 upon under root 2 sigma square plus 1 upon under root 2 sigma square that makes it 1 upon 2 sigma square plus 1 upon 2 sigma square. They get cancelled, so you get 1 by 2 plus 1 by 2, that is going to be 1.